Right. Good evening, everyone. Good evening. Hope you can hear me well. It's raining as well. Yeah. Okay. So we are going to discuss this tutorial number 7, structure and bonding, bond length and oxidation numbers. Tutorial number 7. I hope you have them, right? So this is the tutorial. We have tutorial number 7. Right. Let's look at that. Arrange the following compounds in the increasing order of the bond length. So depending on the bond length. So what are the rules of this? If you look at the bond length, first one you look at the position in the periodic table. You look at the atomic radius. If there are different atoms, first thing that you consider is the atomic radius. If the atomic radius is the same, meaning you have the same atoms that you consider, then you look at the hybridization. So it's if you have a single bond, it is larger than a double bond. Double bonds are larger than a triple bond. And then if you have partial double bonds, partial triple bonds, then you can look at that as well. So this one is bigger compared to this partial double bond. And this is bigger compared to a normal double bond. This is bigger compared to a partial triple bond. And this is bigger compared to a triple bond. But you can discuss that under hybridization. So what is that? If it is sp3 overlap, it is bigger. Then what is the next one? sp3 sp2 3 to 5, right? Then next one is 4 sp2 sp2, or you can say sp3 sp. They come under that category. And then what you have is sp2 sp, right? If you look at this one, it is bigger than, what is the next one? sp sp. And this is bigger than, if you look at this one, this is bigger than S and a S orbital, S and a sp3. This is bigger than S and a sp2. This is bigger than S and a sp. This is bigger than S and a S. Now, so that way the radius decreases. This direction radius decreases. S and a S means is hydrogen, right? Hydrogen, something like that. So radius decreases. And if the hybridization is also the same, if the hybridization is the same, then what is the next thing that you look at? Hybridization is the same. Then you look at the bond order. Bond order is the number of bonds, average bonds, number of bonds divided by the number of surrounding atoms. Number of surrounding atoms. Higher the bond order, lower the bond length. Right? Higher the bond order, lower the bond length. So that's what you're trying to look at. Okay? Right. So let us look at the first example. Right? Let's try understand how this is going to work. Question number 1. Question number 1 comes with this. Nitrogen Cl, NCl, NF, and NBr. Right. So these are all different atoms. Nitrogen is the same atom, but the halogen is different. So if you look at this one, this is 2p, fluorine is 2p, this is 3p, and this is 4p. So you can see NF is the smallest, and then comes NCl, and NBr is large. That's the first one, right? Then let us look at the second one. Second example is SF2, SF4, and SF6. All are sulfur fluorine bonds. Now let us look at the hybridization. What is the hybridization? 1, 2, 3, 4, 5, 6. That means this is sp3. SF4 means 4, another 2 electrons. This is sp3d. This is sp3d2. Higher the S character, shorter the bond length. Right? So this is 25% S character. This is 3, 4, 5, that is 20% S character. This is 1 over 6 times 100, right? So it's less than that, right? You can calculate it, whatever the value. 1 over 6 times 100, less than that. So how does the bond length vary? SF2 is smallest, SF4 and SF6 is the greatest. That's the second one. Third one, higher the S character, lower the bond length. Let's look at the next one. Oxygen, O2, double bond O2. Peroxide, oxygen, oxygen, like this. Minus, minus. O2, then O3, oxygen, double bond oxygen, dative bond oxygen, plus and minus. Now let us look at the bond order. Here bond order, there are two atoms, two bonds around the atoms, right? So bond order is 2. But here the bond order is 1. There's only one bond. 1. What is the bond order here? 1, 2, 3. 3 divided by 2 atoms. Surrounding atoms are 2. 1.5. Higher the bond order, shorter the bond length. So the meaning, oxygen is the smallest, then comes ozone, then comes O2, 2 minus. Right? Higher the bond order, shorter the bond length. Right? Question number 4. How does the question number 4 comes? What is this one? H2O, H2S, and H2SC. They belong to group, what is that? Group 16, group 16, oxygen, sulfur, selenium, tellurium, polonium. So hydrogen is the same. So you look at the central atom. Oxygen is the smallest. Sulfur is bigger. Selenium is the biggest. So it maps that category. H2O is the smallest. Then comes H2S. Then comes H2SE. This is how the variation takes place. Check whether this is okay. Fifth one. Fifth one is this. What do they say? NO2 minus, NO3 minus, NO plus, NOF. So they are looking at nitrogen-oxygen bond length. Look at NO2 minus. This is how the structure looks like. 1, 2, 3, 4, 5. Right? NO3 is this. NO plus means the triple bond oxygen. This is plus. Right? NO 1, 2, 3, 4, 5. Right? NO, NO2, NOF means double bond oxygen, fluorine. Now this can form resonance. This can pump in here, this can dump in there. Let us look at the bond order. Here the bond order. What is the bond order? 1, 2, 3 divided by 2 atoms. 3 divided by 2, 1.5. What is the bond order here? 1, 2, 3, 4. Because it participates in resonance. 5. 1, 2, 3, 4. 4 divided by 3. 4 divided by 3 is equal to 1.33. Here the bond order is 3. Here there is no resonance from fluorine. Fluorine cannot give electrons. So it won't participate in resonance. This gives you a double bond, 2. So higher the bond order, lower the bond length. So what is that? NO plus is the smallest. Then NOF, right? Then you have NO2 minus, then you have NO3 minus. Question number 5 is that. Question number 6. How does the question number 6 work? HBr, HI, HCl, HF. Hydrogen X bond length. So hydrogen is the same everywhere. So it depends on the electron radius of the other atom, the halogen. Which one has the lowest one? Lowest one is HF. Then comes HCl. Then comes HBr. Then comes HI. This is how the radius increases. Question number 6 is that. Question number 7. How do you get this one? C2H6, that means CH3, CH3. It's a carbon-carbon bond length. So it's sp3, sp3 hybridization. C2H4, carbon, double bond carbon. This is hydrogen, this is hydrogen. And this is also hydrogen, then hydrogen. It is sp2, sp2 hybridization. sp2, sp2 overlap. What is the other one? C2H6, no, C2H2. H, C triple bond CH. What is the hybridization? sp3, sp3 overlap. No, not sp3, sp, sp overlap. It should be sp, sp overlap. So if that is the case, you have only 2 p's here. There's 4 p's here. There's 3 p's here. Or you can say triple bond is shorter, then double bonds, then single bonds. So C2H2 is the shortest. C2H4 is the next one. And C2H6 is the next category. Did you understand that? Right? Okay. Question number 7 is that. Question number 8. What is this? Sodium chloride, magnesium chloride, aluminium chloride, AlCl3. Right. So what they ask is MCl bond length. Chloride is the same. Chloride is the same. So you look at the cation, the radius of the cation. Radius of the cation, when you go across the period, sodium plus is the highest. Then comes magnesium plus 2. And aluminium plus 3 is the lowest out of these cations. So the radius also the same thing. Sodium chloride has a higher radius, magnesium chloride has a lower radius, and aluminium chloride has the lowest radius. Is it clear? The last one, the last structure, NOF. NOF can make right? You have lone pairs. I didn't write the lone pairs. Right? It won't participate in resonance. Fluorine cannot donate electrons at all. So fluorine will never participate in resonance. So this has a double bond, just a double bond. Right. Question number 8. That is 8. Question number 9. Question number 9 comes with SO3. Sulfur, double bond oxygen, double bond oxygen, double bond oxygen. Sulfur. SO3 2 minus, S double bond oxygen, O minus here, O minus here, 1, 2, 3, 4, 5, 6. SO4 2 minus, double bond oxygen, O minus, O minus. So we look at the, since they are all sulfur oxygen bonds, we look at the bond order, right? 1, 2, 3, 4, 5, 6, 6 divided by 3 atoms. So bond order is 2. What is this one? 1, 2, 3, 4. 4 divided by 1, 2, 3, 1.33. Okay, 1, 2, 3, 4, 5, 6. 6 divided by 4. That is 3 divided by 2, 1.5. Higher the bond order, lower the bond length. Lower the bond length. So SO3 has the lowest. Then comes SO4 2 minus. Then comes SO3 2 minus. That's how the variation takes place. Right? In question number 7, how did you count P? P is methane. Like, this P, this is 2. This 2, this 2, this is 4. This 3, this 3, this is 6. Where do not no problem. Because single bonds are longer, right? That's how you count the total number of p orbitals. Huh? Question number 9. Question number 10. Look at that. Carbon monoxide, triple bond oxygen, lone pair, right? This is plus and this is minus. Carbon monoxide is that. Carbon dioxide, CO2, CO2. Carbonate, C double bond oxygen, O minus, O minus. So how does the bond order vary? Bond order. Here you have 3 bonds. Here, my God. 1, 2, 3, 4. 4 divided by 2 is equal to 2. Here, 1, 2, 3, 4. 4 divided by 3 is equal to 1.33. Bond order varies like that. Did you understand that? So therefore, carbon monoxide has the shortest bond length, carbon dioxide, and then carbonate, CO3, 2 minus. That's how the variation takes place. Question number 10 is that. Question number 11. Question number 11, it says lithium chloride, sodium chloride, potassium chloride, cesium chloride. Chloride is the same, right? And lithium chloride is the shortest. Sodium chloride is larger down the group. Potassium chloride is even larger. Cesium chloride is even larger. So since they are all different atoms, you have to consider the position in the periodic table. Question number 12. Question number 12 comes in benzene. Benzene is like something like this. Benzene is that C2H6, CH3, CH3. C2H4, carbon, double bond carbon, hydrogen, 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 hydrogen. Right. So if you look at the bond order here, because these are all atoms, if you look at the bond order here, 1, 2, 3. 3 atoms, you have similar carbons, 2 carbons. So 3 divided by 2, 1.5 is the bond order. Here the bond order is 1. One bond. So now if you consider this as one of those central atom, and there's only one atom. 1 divided by 1 is 1. Here you have 2 atoms, 2 bonds, right? 2. So higher the bond order, lower the bond length. Lower the bond length, right? So higher the bond order, so C2H4 is the shortest. Then comes benzene. And then comes CH3, CH3. I hope you got that. Right. Okay. What is the next one? Let's look at the next one. It says question number 13. Question number 13 comes with CH3. You have carbon CH3. You have a double bond CH. And then you have a single bond, triple bond CH. And they have given these letters. A here, B here, the C here, and then this is D. Carbon-carbon bond length. So A is what? sp3, sp2 hybridization. This is sp3, this is sp2. B is sp2, sp2 hybridization. C is sp2, and on the other side, sp hybridization. D is sp hybridization. So count the P. Count the P. 3, 2, 5 here. This is 4. This is 3. This is 2. Higher the number of p orbitals, greater the bond length. Right? So greater the bond length, A is the largest. Then comes B. Then comes C. D is the shortest. D නේද බලන්න හරිද කියලා 3 2 2 4 2 plus 1, 3. This is 2. This is 3. C is 3. 2. C is, it should be the other way around. C is 3. C, and then B, and then A. 2, this is 3, this is 4, this is 5. Did you understand that? So how to draw the hexagon structure for benzene? Benzene is a hexagonal structure. I have given this in the note, right? Benzene structure. We talked about that benzene structure. Benzene is C6H6. It's a hexagonal structure like that, right? Hexagonal structure, carbon, carbon, carbon. This is a carbon. There's another carbon. There's a carbon. There's a carbon like that. So hydrogen. This is also hydrogen. There's hydrogen here, hydrogen here. This is a hydrogen. This is also a hydrogen. And then you have alternating single and double bonds, just like that. Right? Okay. Then next one is XIV. It is 14. Let us look at the 14th one. H, carbon, triple bond carbon, CH2. And then you have carbon H, double bond carbon. This is hydrogen. This is hydrogen. So meaning you're talking about these bonds, carbon hydrogen bonds, A. This is the second one. This is the second one, B. And this is the C, right? So let's look at that. A is s orbital and sp3, sp. B is s orbital and sp3. C is s orbital and sp2. Higher the p character, longer the bond length. So B is the longest, C comes, and A is the shortest. Did you understand that? A, C, B. Right? Then 15. Right? Benzene. Right? And then you have carbon, triple bond carbon, CH2, CH, double bond CH2. A. This is B. This is C. This is D. And this is E. Right. Okay. Right. So let us see what is that. A, if you look at it, it's a sp2 overlap. If you look at B, it is sp overlap. C is sp3 overlap. D is sp3 and sp2 overlap. E is sp2 overlap. Right. So let us look at the p orbitals, right? There are 2, 4. Here 4. Here this is 2. Here this is 4 as well. Here this is 4 as well. Here this is sp2, sp3, 5. All right. You understand that higher the p character, definitely they are longer. So what is that? 5 is D is the longest. D. You say these ones we are not sure. The shortest one is B. Now what you do is you look at, after looking at this one, this is sp2, this is a double bond. This is a single bond. This is a partial double bond. You can see this is a proper double bond. Proper double bonds are always shorter. So E. This is a single bond. Single bonds are larger. Sorry, not there. Short again. You need to write it on the other side. Anyway, shorter is here. E is here, shorter. Right? But what is that? D is a single bond. No, sorry, the C is a single bond. Single bonds are large. And this is a partial double bond there. You don't have a double bond. You don't have a single bond. Partial double bond character. What is that? That is Andeka Terunadu. Did you all understand that part? Did you understand that BEACD is the answer? Finally. Right. If you're okay with that, then we will go to the next one. Right. Okay. So go to the next page. Yeah. Right. Good. Go to the next page. XVI. Right. So what is this? They have given CH3, CH3, CH3. CH, double bond CH, CH, CH3, C, triple bond C, CH3, carbon, carbon bond length. Here it is M, here it is N, here it is O. It's very easy to, because these are triple bond. Triple bonds are shorter than double bonds. Double compared to double bonds, single bonds are long. ONM. XV2, if you look at this one, CH3, CH, double bond CH, C triple bond CH. So here it is P, here it is Q, here it is R, here it is S. So you can see shortest one is S. S is the shortest. Then you get the double bond Q. Then we have no idea about R and P. If you look at R and P, it is sp2 on this side and sp on the other side. This, if you look at P, it is sp3 on this side, sp on the other side. So 2 plus 1 is 3. 3 plus 1 is 4. 4 means, P character 4 means higher radius. So what is that? R is smaller than P. SQ, RP is your answer. Is it clear? Arrange the following compounds, elements, elements in the increasing order of the electronegativity. I think that should be, that you can do easily, but I will explain it. Right? If you look at the elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, calcium, strontium, magnesium, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Yeah, and then bromine and iodine, you have these ones. And you remember how the electronegativities work. We have done this many times. This is 4, this is 3.5, this is 2, 3.0, this is 2.5, this is 2, this is 1.5, this is 1. And the hydrogen is 2.1. If you look at chlorine, chlorine starts with 3. Sulfur is 2.5. Carbon and sulfur, sulfur is slightly more electronegative. And then you get 0.4, 2.1, 0.3, 1.8, 0.3, 1.5, 0.3, 1.2, and this is 0.9. And then bromine is 2.8, iodine is 2.5. That's how the variation take place. So if you look at oxygen, sulfur, carbon, oxygen, nitrogen, sulfur, and fluorine, carbon, oxygen, nitrogen, sulfur, and fluorine, you know fluorine is the most electronegative. Then comes nitrogen, then comes oxygen. If you look at carbon and sulfur, sulfur is slightly more electronegative than carbon. So something like that. All these other elements are like that. If you get this data, if you can put this data, I think you should be able to arrange this. So I'm not going to waste that time, like a lot of time, because I've been through these numbers. So it's a matter of arranging these numbers. If you look at nitrogen and chlorine, chlorine is slightly more electronegative. Right. Let's go to question number 3. Question number 3 there, right? Arrange the following compounds in the increasing order of the electronegativity of the given atom. So if they ask you to arrange the electronegativity of atoms, you come up with various types of there's a checklist that you look at. First one is the position of the periodic table. This checklist is important. Position of the periodic table. Position in the table. I'll say PT, periodic table. The second one is you look at the what is that first one? Hybridization. Hybridization. Under hybridization, sp hybridized is more electronegative than sp2. Sp2 hybridization is more than sp3. Right? Higher the S character, greater the electronegativity. Third one, what is the next one we look at? We look at the charge on that. Charge. If you have a positive value, it is more electronegative than neutral. Neutral is more electronegative than a negative value. Right? Fourth one is the oxidation number. Oxidation number. Higher the positive value, greater it is. Then the next one is other atoms, surrounding atoms. Surrounding atoms. If they withdraw electrons, then that particular atom is more electronegative. More electronegative. If they donate electrons, it is less electronegative. That's all. Isn't oxygen greater in electronegativity than nitrogen? Oxygen is greater. Yes, oxygen is greater. Yes. 3.5 මේ මේකේ තියෙනවනේ ඉතින් කියන්නේ ඉතින් අහන්න දෙයක් නැහැ. 3.53. ඒක අහන්නවත් දෙයක් නෙවෙයි. ඒක දැන් අපි කතා කරලා තියෙනවා ගොඩ දවසක්. Yeah. Right. Yes. Right. So oxygen and nitrogen, you know this value. මෙතන පේනවනේ 3.53. Right. Okay. So these are the ones that are there. Right. Okay. So now keep that in mind. And we'll work on this one, right? First one is this. What is that? NH4 plus, NH2 minus, and NH3. So everything is nitrogen. Everything is nitrogen. So hybridization is sp3 here. This is also sp3 here. This is also sp3 here. Now you go to the charge. Charge is positive on nitrogen, negative on nitrogen, neutral here. So what will happen? Having a positive charge is more electronegative. So ammonium is more electronegative than ammonia. Ammonia is more electronegative than NH2 minus. Check whether you are okay with that. Right. Can you explain about the charge? Higher the positive charge, greater electronegativity is. Positive charge means it has lost electrons. Whenever you lost electrons, you want to gain electrons. Right? You become very electronegative. Then, like, for example, if you lose marks at the exam, you want to try and gain marks on the next exam. So it's you become hungry for marks. So just like that. Right. Okay. So nothing to do with the bond order has nothing to do with electronegativity. Right. These are the five points. Right. So the second one. Second one is carbon monoxide, carbon dioxide, and carbonate in CO3 2 minus. Carbon monoxide, carbon triple bond oxygen. You have this This is plus and this is minus, I think. Right? Carbon dioxide, CO2, just like this. Carbonate is O minus, O minus. So this is sp hybridized. Carbon is sp. This carbon is also sp. This carbon is 1, 2, 3, sp2. Sp hybridized carbon gets a what kind of a charge? Negative charge, neutral. And this is also neutral. Right. So let us see how the electronegativity work. Negative charge and CO2 is more electronegative, right? Why? Because it doesn't have a negative charge, right? So carbon dioxide is the most electronegative. Then comes carbon monoxide. Then comes carbonate ions, CO3, 2 minus. So that's how the electronegativity vary, right? Third one, SO2, SO3, 2 minus, and SO4, 2 minus. SO2 means you have a sp123, sp2 hybridization. SO 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. That is also sp3 hybridized. SO4, 2 minus, that is also sp3 hybridized. sp3 hybridized, right? So since they are sp3 hybridized, now let us look at the charges. Charges are 0, 0, 0. So from charge, you can't say anything about this. Now look at the oxidation number. Oxidation number is +4. This is also +4. This is +6. Now I think we can arrange. Right? sp2 is more electronegative. SO2. Right? These are both sp3. Now you get SO4, 2 minus times SO3, 2 minus. Did you understand that? Right? Question number 4. Question number 4, if you look at this one, O2 minus, O2 and O plus. So how does that work? O2 minus, oxygen, 1, 2, 3, 4, 5, 6, 7, 8, minus 2. O2, double bond oxygen. O plus, 1, 2, 3, 4, 5, and there's a plus charge, right? So if you look at that, you can see this is like, you go with the hybridization first, hybridization. Hybridization, this is not hybridized, it's a single atom, right? Not hybridized. If you look at this one, this is sp2 hybridized. This is also not hybridized, right? So if it is not hybridized, we say O2 is the one that is having a greater electronegativity. Now you have a positive charge and a negative charge. If you have a positive charge is much more electronegative than having a negative charge. Right? But in a single atom, you can't talk about electronegativity. Why? Because there's nothing from from where it can withdraw electrons. So it's like, it's like redundant because you can't withdraw electrons from anywhere, and because it's a single atom. There's no one else to bind. You can't really say anything, but that is how you kind of classify them, right? Okay. What is the next one? Next one is 5. 5 is NO2 minus, NO2 plus, and NO3 minus. Let's see how this is going to work. NO2 minus, double bond, oxygen, negative charge. 1, 2, 3. It is sp2 hybridized, right? NO2 plus, NO2 plus is something like this plus. So it is sp hybridized. NO3 minus is double bond oxygen. This is negative, and this is plus positive. 1, 2, 3, that is also sp2 hybridized. So these are how the hybridization work. Right. So from hybridization alone, you can't say anything. So you need to look at the oxidation number as well. What is the oxidation number here? I think it is +4 nail. NO2 minus the NO2 minus is +3. What is this one? NO3 minus. NO3 minus is plus 5. Right? Plus 5. So NO2 SP. NO2 plus is the most electronegative. Then you get nitrate, NO3 minus, and then NO2 minus. Did you get that? Right? Is it clear? 5. 6. What is this? NO2F. Dative bond plus and minus F. NH3. And NO4 3 minus. This is minus, 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 and this is plus. Let's see how this is going to work. What is the hybridization? 1, 2, 3, sp2. This is 1, 2, 3, 4, sp3. This is 1, 2, 3, 4, sp3. Then you look at the charges. Here the charge is 0, here the charge is plus 1. Right. So what do you get? You get sp2 is more electronegative, NO2F is more electronegative. Out of these two, NO4 3 minus is more electronegative than NH3. Because there's a plus charge, there's a zero charge. What is H2S? It should be H2S. Yeah, H2S. It's there, but the S is subscript. H2S. It was what is this? SO2, and the other one is SO3. Right. If you look at sulfur, hybridization is sp3. SO2 hybridization is sp2. SO3 hybridization is also sp2. Then we need to look at the oxidation number. This is plus 4 and this is plus 6. Right. So how do you get that? This is the least electronegative. And SO2 is the next one. SO3 is even more electronegative. Did you understand that? Yeah. Right. Okay. You say 5 plus 3, 8. Hydroxyl OH minus, H2O, and H3O plus. Let us look at the hybridization there. Hybridization is sp3. This oxygen is also sp3. This oxygen is also sp3. Now, from sp3 alone, you can't say anything about this. So you need to get the next one. Next one is -1 charge. Here the charge is 0. Here the charge is +1. So therefore, H3O plus is the most electronegative. Then comes water. Then comes OH minus, hydroxide. Right, okay. Now let's look at the next one. So if they have given CH3, carbon CH3, CH3, CH double bond CH, you get CH, CH3, carbon, triple bond carbon CH3. Right. So hybridization, this is A, this is B, this is C. A is sp3 hybridized. B is sp2 hybridized. C is sp hybridized. So C is the most electronegative. Then comes B. Then comes A. C, B, A. Most electronegative ones. Right. Okay. Go to the next one. So you get CH3, CH3, double bond, CH. Then you have a single bond, triple bond, CH. This is A, this is B, and this is, no, not B, this is C. This is C and this is B. B is sp. A is sp2. C is sp3. B is the most electronegative. A is the next one. C is the least electronegative. B, A, C. That's how the variation takes place. Now the remaining ones, I think you can do it, but I'll randomly do a few questions. The oxidation number, I've done this lot of examples in the class itself, but we will look at some of those questions. Huh? Oxygen, right, okay. So maybe I will take a picture of this and we'll paste it and try to work it out. Right, I think that will make our life little easier, rather than writing everything again and again. Right, okay. So let's see whether we can do this. Carbon. What is this one? This is -2. -2, -2. This is +4. So that carbon is +4. Oxygen is -2. This is -2. Fluorine is -1. This is +1. This is +1. This is -1. Chlorine. Chlorine is -1. Hydrogen is +1. +1, -1. Sulfur. This is -2. This is -2. Therefore, sulfur is +4. +4, -2, -2. So if you break it here, -2, this is +2. This is +2 and this is -2. So oxygen 1 is -2. Oxygen 2 is -2. This is +2. This is +2. Similar atoms, you don't have any charges to cancel, right? So this is -2. This is -2 divided as +1 and +1. So +1, +2. Altogether +3. Nitrogen is +3. This oxygen 2 is -2. This oxygen is also -2. Did you understand that? Right. If you break it here, to make this pencil very small. Right. Okay. Let us see. Let us see whether you can get that. -2 here, -2, and this is +2 therefore. Carbon and nitrogen is more electronegative. This is -1, this is +1. This is -1, this is +1. Right? So nitrogen 1, nitrogen 2, and oxygen. Nitrogen 1 is -2, isn't it? But if I am making many mistakes, nitrogen 2 is +2. And oxygen is -2. Is it clear? Now let us look at this one. Nitrogen and carbon. Nitrogen is more electronegative. -3. You have to break 3 bonds here. This is +3. When you break it here, this is -1. This is +1. So nitrogen is -3. Carbon is +4. Oxygen is -1. Right? Carbon, nitrogen, oxygen. Carbon. Carbon and nitrogen. Nitrogen is more electronegative. -3. And this is +3. Hydrogen and carbon, this is -1. Hydrogen is +1. So carbon is +3 -1 +2. Nitrogen is -3 -3 -3. If you break it here, this becomes +1 and this becomes -1. Altogether charge -3 +2 and -1. Oxygen is -2. Is it clear? Did everybody got that? It should be -2 for oxygen. Oh, yes. Which one? Yes, -2. Yes, you are right, Pudha. Very good. Right, okay. NH3. Yes. NCO. Yes, -2. You are right. Yes, thank you. Because there's another negative charge. I didn't see that. NH3, nitrogen and hydrogen. Nitrogen is -3. NO4 3 minus. NO4 3 minus is like this. Minus, O minus, O minus, O minus, and this is plus. How do you get the charge? +1, +2, +3, +4, and with that electron, positive charge, +5. Oxygen is minus 2. Check whether you are okay with that. Next one. Oxygen minus 2. This is plus 2. Fluorine minus 1. This is plus 1. Oxygen minus 1. This is plus 1. Oxygen A is minus 2. Nitrogen is plus 5. Oxygen B is minus 2. Nitrogen is 0, isn't it? Oxygen A, break the bond. 0, right? Break the bond. This becomes minus 1. No, this is all 0 and this is 0 as well. So oxygen B is plus 1 and oxygen C is minus 1. Did you understand that? Right. Okay. Right. SCN minus sulfur, carbon, triple bond nitrogen, minus charge is on this side. Sulfur and carbon and nitrogen is more electronegative, minus 3. Yeah? Nitrogen is minus 3. Carbon and sulfur is slightly more electronegative. If it is that, you get minus 1, minus 2, carbon minus 3 plus 3 plus 1, that is giving you plus 4. Nitrogen Na, Nb, Nc. Na, if you break it, nitrogen 1 is minus 1. Nitrogen B is plus 1. Nitrogen C is again minus 1. If you break it, even. What is the next one? Cn. Cn is carbon, triple bond nitrogen, and then negative charge is on this thing. Right? This is minus 3. Carbon is plus 3. Plus 3 minus 1 plus 2. Hydrogen peroxide, you break it evenly. This is minus 1. Oxygen 2 is also minus 1. Is it clear? Since we have little bit more time, I will do the next page also. Right. We'll finish this also. Right. So what is the verdict for this one? Oxygen, sulfur, that is 0. Sulfur 1 is 0. Minus 1 plus 1. Oxygen 2 minus 2 plus 2. Oxygen 2 is plus 2. Oxygen 3 is the minus 2. Minus 2. You got a plus 4 endo. Oxygen 1 is also minus 2. Right. Nitrogen minus 2 plus 2. Plus 1 minus 1. So nitrogen 1 is plus 3. Nitrogen 2 is also plus 3. Oxygen 1 is minus 2. Oxygen 3 is minus 2. Oxygen 2 is also minus 2. Right? Which nitrogen? Plus 6 in the back. Nitrogen ever cannot be plus. Nitrogen cannot be plus 6. Plus 6 can do go ahead. Which nitrogen? Right. Sulfur dioxide is plus 4, right? Oxidation number. Hydrogen sulfide is minus 2. Check your answers. Sulfur trioxide is plus 6. H2SO4 is plus 6. H2SO3 is plus 4. SO4 2 minus is plus 6. S2 minus is minus 2. S8 is always 0. CrO plus 2. Cr2O3 is plus 3. CrO3 is plus 6. Algebraic method. CrO4 2 minus is plus 6. Cr2O7 2 minus is plus 6, I think. MnO2 plus 4. MnO4 minus plus 7. MnO4 2 minus plus 6. Mn2O7 plus 7. MnO plus 2. P4 is 0. H3PO4 is plus 5. H3PO3 is plus 3 ne? H3PO2 minus H3PO H3H and there's nothing called H3PO2 minus right? HClO4 is plus 7. HClO3 is plus 5. This is plus 3. HClO2 is plus 1. Chlorine is 0. NO2 minus is plus 3. NO3 minus plus 5. NH4 minus is equal to minus 3. This is plus 7, right? Mn2O7. POCl3, 2 plus 3, 5, plus 5. ClO2, Cl2O7 plus 7. N2O3, there are two structures. If you look at the symmetric structure, it will be plus 3. If you look at the asymmetric structure, you have two answers. This one is plus 2. This one is minus 2 plus 1 plus 3 plus 5. This is plus 5 because there's a negative charge and there's a positive charge. 5 plus 2. I will draw that again. N2O3 asymmetric structure. Minus and plus. So if you look at it, this is minus 2, this is plus 2. This is minus 1, this is plus 1. This is 0, this is 0. So 2, 3, 4. This is plus 4 oxidation state. This nitrogen is plus 2 oxidation state. 4 plus 2 is 6. If you divide it by 2, you get 3. That's how you get 3. What is that? In fourth question, ninth one. Fourth question, ninth one. Yeah, ninth one. Yes, what is the problem? Fourth question, ninth one is this sulfur, oxygen minus, oxygen double bond, oxygen minus. So what is this? We look at it. This is 0. This is 0. If you look at this one, this is minus 1, this is plus 1. If you break it, this is minus 2, this is plus 2. If you break it, this is minus 1, this is plus 1. So altogether, this sulfur is plus 4. This oxygen is minus 2. This oxygen is minus 2. This oxygen is minus 2. Anything else? Yeah. Okay. Boiling point question doesn't come under this category. It comes under the intermolecular forces. When we're discussing intermolecular forces, we'll look at that answer. We'll try to come up with that. Right. Okay. X2, 2 please. XI. Wait. XI is X2I. NO2F. Right. So if you look at this one, nitrogen, double bond oxygen, fluorine, and oxygen. This is plus and this is minus. Right. So if you break it here, minus 2, this is plus 2. This is minus 1, this is plus 1. When you break it, this is minus 1, this is plus 1. So altogether, this oxygen is minus 2. This nitrogen is 2, 3, 4, and this one is 5, plus 5. This is minus, minus, minus 2. This fluorine is also minus 1. What is formal charge? Formal charge is the charge accumulated on the atom. Whatever the charge that is present on that particular atom is called the formal charge. So there we will stop today, right? And then we'll continue. Now the next week, I will discuss this part. What is the part that we are going to discuss? The one that I haven't discussed is The next one is now we need to start discussing chemical calculations also. So I have to discuss tutorial number 8. Tutorial number 8 means structure and bonding. एक complete करना. Tutorial number 8, complete that structure and bonding, and we'll discuss that. And then we'll start chemical calculations. We want to very quickly move on to chemical calculations now, right? Okay. And finish those other questions. Huh? Morning, and then we can start chemical calculation properly, right? Directly, right? Okay. And Aputala, good night, huh? Right? We'll meet on Saturday, right? Good night.